The U.S. Marine Corps has tested a four-legged robot designed to help carry fighting loads on the battlefield during testing on November 6, 2013, at Fort Devens, Mass. After a quick class to learn about the legged squad support system's controls and wearable sensors, the Marines walked with the robot, which could either follow the operator or proceed in a programmed line of travel. At first, I thought it was going to be complicated to operate, but it turned out to be simple, said Private First Class Marcus Beadle, a rifleman serving with the 1st Battalion, 5th Marines. Created by Boston Dynamics, the robot is designed to reduce the load Marines haul on their backs without interfering with the team's mission. It's basically a robotic pack mule, said Kevin Blankespoor, chief engineer of the LS-3 project. The goal of this machine is go to where the warfighter goes while carrying their load. The 1,300-pound robot is equipped with 3 joints on each leg to provide optimal mobility, and inside the body is a single-cylinder, 4-stroke gasoline engine. A sensor on the robot's head helps it navigate rough terrain and detect when humans or another robot dog is nearby, allowing it to follow its owner and run in formation. It also can walk and trot over uneven terrain and climb stairs. Carnegie Mellon's National Robotics Engineering Center and NASA's Jet Propulsion Laboratory created the control and computation sensors, which track 2 black strips on the back of the operator and recognize terrain like rocks, trees, and bushes. The robot can decide whether to continue or walk around an obstacle. The Marines gave feedback to the robot's development team, whose members said the robot had undergone drastic improvements since its beginning, and engineers are already working on improvements to mobility, stealth, and protection. Brigadier General Kevin J. Kiley, Marine Corps Warfighting Lab Commanding General, said the Marines testing the robot saw its value. If you ask them if they want 400 pounds off their backs, I think they'd be in agreement with that, whether that's ammunition or supplies, said Kiley. We feel like it's going to get there. The technology has come a long way. The LS-3 is a robotic mule capable of traversing rugged terrain with Marines while carrying much of their load. It is programmed to follow an operator and detect large terrain objects to maneuver around. The Marine Corps Warfighting Lab observes the testing for the LS-3 during the Advanced Warfighting Experiment as part of RIM of the Pacific 2014, a military multilateral training event featuring 22 nations and roughly 25,000 people. Lance Corporal Brandon Dickman, a native of Las Vegas, remembers watching clips of the LS-3 on YouTube before he joined the infantry. He said he never would have guessed he would be chosen to operate the machine, which has been affectionately nicknamed Cujo by his company. The Marines used Cujo to conduct resupply missions to the various platoons around the training area. The LS-3 brought water to service members in terrain inaccessible by all-terrain vehicles. I was surprised how well it works, Dickman said. I thought I was going to be stumbling around and losing its footing, but it's actually proven to be pretty reliable and pretty rugged. It has a bit of a problem negotiating the obliques and contours of hills. The LS-3 is being used as a logistical tool during RIMPAC instead of a tactical tool due to its loud noise during movement and problems traversing certain terrains. I'd say 70 to 80% of the terrain we go through, it can go through, Dickman said. There are times when it is going to fall over, but most of the time it can self-right and get back up on its own. Even if it doesn't, it can take one person to roll it back over. The way it is designed is that you can easily roll it back over. However, at that time, the robotic mule is still in development. Dickman said creating more space within the LS-3 for equipment, like heavy weapon systems, would benefit quicker movement in a field or combat environment. Putting the LS-3 in the hands of young Marines is vital to the development of the program, said Ben Spies, a contractor with Boston Dynamics, observing the AWE. We give the military hands-on, so we can see what they will use it for instead of putting it in a parking lot, Spies said. This is the first time we put the LS-3 in a training environment like this. They push it to the max. It helps us develop it more, because right now, only the engineers have it. Dickman also said he looks forward to seeing future developments in the program. It would be pretty crazy to see a later version of it 15 to 20 years down the line, and be able to say I was one of the first groups that tested it and brought it to the field on one of the bigger training exercises. Dickman said, "It's pretty surreal." But unfortunately, the U.S. Marine Corps has abandoned plans to use a robotic mule in combat situations, claiming that the amount of noise it makes risks giving away the position of troops to the enemy. The LS-3, or Legged Squad Support System, had been the centerpiece of a significant push by the U.S. Army to integrate thousands of robots into its forces by 2030. Development of the LS-3 first began in 2008 after the Defense Advanced Research Projects Agency, or DARPA, offered a $32 million contract to Alphabet's Boston Dynamics. A further $10 million was awarded in 2013 for testing the quadruped robot, demonstrating that it could carry loads of up to 180 kilograms across rugged terrain. The noise produced by the gas-powered engine of the LS-3 robot was cited as a major issue by Marines in tests and proved to be a challenge that engineers were unable to overcome. As Marines were using it, there was the challenge of seeing the potential possibility because of the limitations of the robot itself. Kyle Olson, a spokesperson for the Marine Corps Warfighting Lab, told military.com. They took it as it was, a loud robot that's going to give away their position. We tend to make things that are fanciful and strange. Learning from it was a big part, and we're still learning.